Hello, this is my lab video for Lab 4 about oscillation. The purpose of this lab was to measure the motion of a mass attached to a vertical spring after releasing it from some elevated position that was shifted to the side and compare it to a computational model, and with this to calculate the energy change of the system through different time points. The main result of this lab was that the computational model was very close to what the experimental data showed, and it showed that the total energy stayed zero following the energy principle throughout the experiment. The fundamentals of this lab include Newton's second law, which is given by the net force equals mass times acceleration. The net force in this case was the spring force and the force of gravity, which are shown to be calculated by these equations here, and then also the velocity and position update formula. Since the force of the spring is not constant, V average is known to be V final. Another fundamental was the energy principle, which was given by this equation here, where the change in energy of the system equals the work by the surroundings plus the heat. The change in energy of the system was given by the change in kinetic energy plus the change in gravitational potential energy plus the change in spring potential energy, and the work by the surrounding and the heat was zero. And the change of the energies is given by these formula. The model for this experiment included the system being the mass, the earth, and the spring, and the surroundings was nothing. That way that the work done by the surroundings could be set as zero. And then our initial conditions were the mass, which was 0.402 kilograms, the position was this in meters, the velocity was zero, the length of the spring at rest was 0.7 meters, and the initial length of the spring was 0.123 meters, while the spring constant was 6.83 Newton meters. In the experiment, the spring was attached to a fixed point up here, and it was dropped from somewhere to the side and elevated and left to oscillate over time, and the position was tracked throughout time. The code was very similar, and we used a time step of 1 divided by 210 since this was a multiple integer of the time frame of the video, which was a frame every 10.5 seconds. G is 9.8. The spring constant was put in, so were the initial conditions as mentioned earlier. The L and L hat were calculated here along with the energy initials, and then in the while loop we had the gravity being calculated, the force of the spring being calculated to get the net force, and using that the velocity and position update formulas were used to track the ball throughout time, as well as updating the new forces or new energies of the system at each time point. The results showed that the overall change in energy was zero throughout the entire experiment, while the delta U spring and delta U grav oscillated back and forth along with the delta K. It can be seen here that the exposition of the spring and the model were very close, although the model was a little bit behind compared to the spring. The Y position was fairly accurate, but it continued to have much higher peaks of the oscillation than the actual experiment did. The error from this lab included that the system was not truly isolated from the surroundings. This is because work will be done by the surroundings changing the internal energy, and some energy could be dissipated by heat or as drag, which is kind of seen as the maximum height in the Y direction getting smaller throughout time. Additionally, the center of the mass and tracker was not accurately placed because the image was very blurry at some frames and hard to place. For the first what does it mean question, is the energy principle satisfied in this experiment? And the answer to this is yes, because the internal change in energy is zero since there is nothing in the surroundings. This is found by summing up the potential energy of gravity, the potential energy of spring, and kinetic energy, and they stayed at zero throughout the entire experiment, showing that no external work was done. For the second what does it mean question about the period of oscillation, it was found that in the x direction, measuring the period of oscillation, which was the time between either troves or peaks, was an average of 1.6334 seconds, and in the y direction it was 1.5194 seconds. This shows that the oscillation in the x direction was slightly longer than the average time of oscillation in the y direction. And this can be accounted for by the fact that the x direction only had the spring force acting on it, while the y direction had both the spring force and the gravitational force acting on it, which would cause the change to occur faster. And that is all I had for this post-lab video. Thank you.